didn't have to make that day. I'd like to hear something.
It did it on that.
Oh, did it? We'll get started here in just a minute. Really, but all right, people, we're going to get started now. Quick introduction. My name is Patrick Bowler. This is Armand Alexi, and this is Mike Grover over here. We've all worked at DMS for many, many years. Mike and I from the very beginning. I hope you guys are all well. I hope you guys are all protecting yourselves and doing all your social distancing. We have our 6 feet out here. Trying to get a little close on that side, but we're trying to stay our 6 feet apart. And just want to make sure that you guys know that DMS is considered a critical supplier. We are open. We did a lot of social distancing on our floor where we went to immediate second shift to thin out the people on the floor, the production crew on the floor. So we're doing everything we can think of conceivably, taking the temperature of everybody coming in here, but we are open for business. So this is our first webinar. We'll see how it goes. I'm sure there'll be some hiccups at some point, but in this first webinar is just going to be a general discussion for about 30 minutes of some of the topics that you guys put down when you decided to listen to this webinar. After that, we're going to open it up for you guys to ask some specific questions for about 30 minutes after that, if you have some. If not, we'll see. And then when we're done with that, we're kind of hoping you guys will, using the chat screen off to your right, you can write some questions down there, because the next webinar we want to be a lot more focused, and we want to be, basically something maybe a pure Mastercam class, or a controller basic operations, or a video on replacing a belt on a servo motor or something like that. So, and then we'll make that a dedicated one. This one's just going to be a general discussion on what we're talking about right now. So I'm going to start off with some of your safety concerns. I'll probably start every meeting off with some of my safety concerns. So it's always safety first. We recently had an occurrence where we had an incident, and it brought some safety things to the forefront of our thinking. So just so you guys know, as a general statement, your plant managers are basically responsible for the safety around your machines, and you guys should be keeping records that you're actually checking safety on your machines. There should be some log that we have it. I mean, I've walked into plants and I've seen hanging e-stop switches off of the machines, or even the disconnect switch is broken and everybody's bypassing these things. And that is just, you guys are going to get yourselves in a lot of trouble if you actually do that. So you should have some process and some way to monitor what you guys are doing on machines at all time. So, and also, make sure some of you guys remove some of the guardings that's on the machine. Make sure that original guarding's on the machine all times, all right? We don't want anybody to get hurt on any of the machines. That's not fun for anybody. One of the new OSHA rules that came out recently is that if your machine is over 20 years old, you're supposed to actually replace every safety component on that machine. That's a new rule that's coming into effect, I believe, this year, or it came last year, one of the two things. So you need to replace that's every e-stop switch, that's some of the safety relays that we have inside the machines, things like that. DMS is technically, first DMS was made in 2003, so we're not quite there yet. We're 17 years, but just keep that in mind, that's coming. So on that note, again, I believe we could actually do some video evaluations of your machine. So if we could set up a webcam and do a slow walk around your machine, we can actually do an evaluation while we're online with you at some point, and then we'd end up making some suggestions, maybe even stripes on the ground, load areas on the ground, or maybe some extra guarding, or light curtains, safety curtains, or safety mats on there. We can make those recommendations to you. One of your questions on here, someone was talking about, again, this is all about liability I'm talking about right now. One of you guys mentioned, talked about modifying post-processors. Now, that sounds like something everybody should know how to do, but it really isn't. I think some of the most drastic crashes we've had on the machines is someone made a change inside of a post-processor, which affected everything, and then the machine does something that nobody expects. And that's the worst kind of liability when you start modifying posts. So be careful that you should have a professional doing that when you are modifying the posts. Ton of responsibility on that. That's basically all I'm going to talk about on safety. Again, this is a quick 30 minutes we're talking about right now. So I'm going to hand you over to Armand here in just a second. Again, don't forget we're going to do some Q&A after he's done. One other thing I'm going to talk about from preventative maintenance, and it's always kind of a unique conversation when I'm talking to customers, and that is when you really think about your machines, the way DMS makes our machines is like, the question you should ask sometimes when you really want to do a PM on your machine is, how do I make my machine as good as new? Because the basic core of your machine, your ball screws, your gearboxes, your rails and runner blocks, if you added that all up, that's not a very big number. So I mean, if you had a machine that was 10 years old and you said, I want the rails and ball screws to be new, that's not a huge number. So you might want to think about just replacing all of those things. I'm not trying to generate business out of this, but when people say, how good is my machine? But the thing that does get expensive, obviously, is when we talk about technology, because it's really technology that you want to upgrade. But from a mechanical, and you have a dedicated job and what you're doing, the mechanical stuff is the easy part, so keep that in mind. So at this point, I'm going to hand it over to Armand to talk about, he's going to move into machine maintenance and PM schedules.
Right. So I'm going to pop up on the screen here, and thank you, Patrick. And let's see. And I just want to share with everyone essentially our 100-point service checklist. When we go through a preventative maintenance checklist on site, this is what we look at. Hopefully this is.
Can you just zoom a little bit bigger?
Large enough.
Up, straight up top.
Straight up to this.
There we are.
There you go.
But much like anything, cars, these machines, they last as long as good as you take care of them, right? Some people's cars last longer than others, and that's no accident. The same as machines, and we see it constantly as we head out into factories and service machines, and some people take better care of machines than others, and are more careful with machines. Some have a more regimented maintenance schedule on machines, and it's very obvious when we go out and evaluate machines, repair machines, or do preventative maintenance on machines. Really some of the biggest things about DMS, in the sense that DMS machines are built to be workhorses, and no doubt about it, they are that. But they do need some maintenance, and they need attention and awareness applied to them. So if you hear anything that does not sound right on your machine, give us a call, and we would be happy to help you with that. Of course, we hear about so many different things that can happen on machines. At our call center, we try to log and bring these things up amongst ourselves, increase our knowledge and awareness, so that we can share that with you and help you keep your machines going as best as possible. So if anything doesn't seem right, doesn't sound right, isn't acting right, please give us a call, and we're here to help you with that. Absolutely. So moving on from through some of this checklist, a lot of the general things that we're looking for is just really making sure everything is performing and is set to how it left our factory. Many of these items are either marked on the machine itself, so that you have a reference right there. And if not, there are ways of finding what this value should be, or perhaps, and in some cases, some of these values could change as far as air pressures, levels of things, pressure checks on machines. It could be a myriad of things, and of course I need to talk in a very general sense, as we have a number of different customers here listening to this. But checking the air balance and the Z balance regulator pressure is something that we want to do on a semi-regular basis. That should not just change unless the shop air is changing drastically and dipping pretty low. Something to be aware of, no doubt about it. Machine levels, lubrication levels, ensuring that the machine is lubricating, whether you have an auto lube system or it's a manual application. This is one of the biggest items, is just keeping the machine lubricated. That's something that needs to happen with the greatest frequency, is lubricating the machine. And if we do that, your machine has a leg up compared to some others. Something to consider there is the environment that the machine is in. Absolutely, if we're cutting carbon fiber, keeping that fiber out of the runner blocks, off of the lead screws, everything lubricated, we're doing the machine, again, another favor. And then that's really what this is all about. Do the machine as many favors as you can, and it's going to do you as many favors as possible. There's no way for us to cover all of these points in here, and this checklist is something that I can share with anybody that's interested, or perhaps we'll have a way to share with everybody, or have some kind of repository for us to give you guys access to getting the checklist, so that you can evaluate the checklist, go through and check all of the different points of the machine that applies to your machine. And if you have any questions, or if something's not right or seems off, give us a call. We're happy to help you with that, especially at a time like this when travel is not easy for anybody. Going somewhere is not easy for anybody. The least we could do is help you take care of your machines the way that we would. Testing limit switches. This is something that some people might not think of, and is something that's not as easily done from a common standpoint, in the sense that this requires monitoring a PLC, and that is, again, something that we're happy to help you with. Give us a call, and we can tell you how to monitor the PLC, what section to go to, and we can check a few items in there. Occasionally, there are issues with spindle sensors, and again, monitoring of the PLC is a great way to evaluate those, amongst other things in the machine. Ultimately, we can see any questions that pop up in the chat box. If anybody has any specific questions, please load those up in the chat box. I will take notes as I see them come up, and if it's something that pertains to preventative maintenance, we'll circle back here towards the end. Again, this is a very general topic that changes for all different machines. So it's impossible really to go through every single point here and stick within our time budget. But I welcome you to ask any questions down below, and I will address as many questions as possible. Anything else you'd like to add to that, Patrick or Mike?
Yeah, I have a couple things to add to that. One thing that's happened to me, I've probably done 1,000 installations and service calls in my lifetime, but it's pretty ironic as owners of the companies here, when you're paying us a ton of money to come out and work on your machines, we get there and the whole area is dirty and the machine is dirty. I mean, so I might spend 4 or 5 hours just sweeping up and cleaning up around the machine, and that's probably the highest paid sweeper you'll ever know. So it really is worth it to have I'm sure everybody has some type of a cleaner guy around there to prep the machine, because you want to get the most out of this service guy that comes to see you. So take the time to make sure your machine's clean. And then, as an example, as I was talking earlier, this entire checklist could be its own focused webinar. So we could set up a video thing, and we probably wouldn't go into detail, but we could quickly, in probably an hour's time, at least show you what everyone, and point, and we'll have someone wearing some GoPro on there and walking around the machine as he's doing these things on the machine. So that might be a suggestion for you guys later to actually do that. Mike, did you have anything to say?
The only thing that I'd like to add to this, and Armand covered it some, but it's cleanliness. You'd be amazed at how many times we go out to work on a machine or we get a call from a customer where they're having a machine problem and it ends up being a buildup of dust or chips somewhere in the machine that's creating the problem. And it's just because the machine wasn't cleaned daily. I mean, we would recommend that you clean off your lead screws, you clean off your rails, and just make sure the machine's not getting bound up on a daily basis due to chips. And so you'd be amazed at how many problems that alone will solve and how many service calls it'll eliminate.
It's hard to catch a problem if you can't see it or if debris is hiding a potential issue. Certainly, I've seen that a number of times. Tim Olson asked, what is your recommended way to clean your linear bearing blocks? But, you know, and some blocks are different than others. Some have Viton seals, some don't. But wiping the rails and making sure they're lubricated will help the blocks greatly. But sometimes we'll see debris build up on the blocks as well, and just trying to remove it. You know, sometimes and often we carry small terminal block screwdrivers, and I'll use that to pull gunk away from the bearing block. Sometimes the lubrication, if it's not wiped off on a semi-regular basis, it starts to harden, and that grabs more debris and more debris over time. So really the best way to clean those blocks, I would say, is often. You know, once a week, if we're wiping them off and making sure that they're clear of debris, then the less buildup gets to build up. And it varies on what kind of environment we're in. But if we keep it clear, it stays clear. You know, it's just kind of that common sense type of thing. But it's easy to get wrapped up in production, everything go, and especially if there's bellows hiding it and you can't see it. Which brings us back to the 100-point checklist and just something good to run through on a semi-regular basis of just checking every component of the machine, making sure we're good. If we do that, we're aware of what's going on in the machine, and we know we're good or we know we're not. We can catch it hopefully early on before it becomes a more expensive problem.
The other thing I'd add to that is make sure you clean them from the inside out. Make sure you keep plenty of lube flowing through them, coming from the inside and pushing out.
Absolutely.
Another answer to that question, though, if the machine has been less than optimally maintained,
Yeah.
The answer is, if you feel it is binding up, is really to flush it out with WD-40. So, I mean, it's the best thing for me if you were to keep, lube up the rail, run it back and write a little program to run the machine back and forth. And if there's black stuff coming out on that rail, keep spraying it on there until it doesn't come out black. I'll continue wiping off. Now, don't be wiping it off while it's running. So, but that's the only way to really flush the thing out. And some people actually do. They actually take it apart one at a time. But that's a full-time job, if you know what I mean. If it gets too bad. Okay, I'm gonna step onto another section. I'm gonna step onto another section here for just a second. There was about 8 questions that you guys asked for on testing. What? Testing. Is that what you call it? Testing.
Yeah.
It's all about. A lot of you guys said, test running programs or programming or tips and tricks, and again, that I could talk for, I'm sure, 2 hours just on those topics. So again, we'll try to get a little more focused and I can answer better. But what I think you're doing is really just dry running. So if you're trying to test a program before you run it, obviously the preferred way is to go to your graphics mode on either an 8065 or an 8055 and run it through its basic graphing test. And that'll tell you if there's any flaws in your program that, you told the machine to go 1,000,000 miles off track, or you have some type of just programming error from a formatting standpoint. Other than that, from test running, there's a couple other tricks you can do. Now, if you guys might not be too familiar, but there is an option in the control. Not all the machines have them. They all have them, but they're not enabled. So there is a block skip feature that's in your machine to where if you wanted to dry run the machine, for example, without a spindle being on, you could, put a slash in front of it, enable the block skip, and it won't turn the spindle on while you run that program. So there's dry run and testings, without the spindle being on. That is a doable thing to do, and that's something if you guys are interested in, give us a call back after this meeting, and we can give you some more details on that. Other than that, the recommendation is, never trust the program the first time, right? Never. Don't know how good. I don't care how good of a programmer you are. You're going to have to assume that it's going to crash the first time you do it. And I say that just to be on the safe side. So always have your feed rate knob at 0 when you hit that cycle start button, and just slowly watch it the first time. And after you've run a couple parts and you start to trust it, that's when you just gun the thing and make it run your production on there. But we do have new people now. There's old customers that, they knew every G code and every line of the code that's going in the machine. And now people are just using CAD/CAM, and they press a button and they're making assumptions, and they don't even know what a G code actually means. And they make assumptions that the machine is just going to do it, the easy button. There isn't quite an easy button for a 5-axis machine tool yet that I know of.
Still working on
there, there's wraparound problems and issues like that you have to be aware of. And it's hard. Like, again, a lot of shops have programmers, and then they have operators. So as an operator and someone handed me a program, boy, there's a huge amount of trust that has to happen in that. And they just have to go slow on that thing. Tips and tricks. A lot of people don't even know what the G49 command is on an 8055. If you don't know what that means, it's basically incline plane definition. If you've ever been running a 5-axis tool path with a long tool and it dove into the part, and you tried to get that tool out in 5 axes and you can't jog it straight out, that's where you want to actually enable that incline plane definition. So when you jog the Z-axis, it pulls straight out of its own hole. Again, these details are in the manuals, what a G49 does. And again, this is just a general discussion that we're having right now. So I'm going to not get into too much details unless you guys later ask me a specific question. I'll give you some better examples on that. And let's see, actually, I didn't even read these other ones here. Optimizing workflow manufacturing. So when someone was talking about optimizing manufacturing workflow, some of the people in this room here are actually experts at that. I see Bob Porsche is online. Last time I was at his shop, he actually had one of the best systems I've ever seen. It really is. We offer a Simco package that goes with our machines. It offers a barcoding and reading system and a way to manage, and document all of your MDM, machine material handling stuff. But it'll record your, what program to run at what time, how long the load time was, all those things. And it's a very powerful program that we can put on the machine. And a lot of people don't want to spend that kind of money either. We have cheaper ways to actually document and store data of what's been run on the machine that we can embed in the machine. So if that's something interesting to you, please call us back on that. And then Mike Gayford, is Mike Gayford on the line? I don't see him on there. I'm going to skip that then. And then Bob, if you have, I can call you after this meeting and we can talk about your list of questions on there. I'd love to talk to you anyway. Hope you're doing well. And at this point, I'm going to pass over to Mike, answer a few more questions.
All right. I'd like to talk just a little bit about troubleshooting. There are many, many facets to troubleshooting. And I'm sure there's quite a few questions on here. So today I just want to focus on troubleshooting errors that come up on the controller, or focus on problems that are going to produce errors. So depending on what kind of controller you have, what kind of drive system you have, you're going to get different errors that pop up. And to help us help you, essentially, the best thing that you can do is when an error comes up on the screen, take a picture of that error or write it down, just so we have some idea of what the exact error is. There are thousands of them on the controls and on the drives, And so the more information you can provide when you call us, the better we are able to help you. But just for some general rules, on the Fagor screens, both the 80, well, actually all the Fagors follow basically the same rules. If it's a 3-digit number that pops up, it's typically going to say drive error and then a 3-digit number. Well, you can find that 3-digit number inside the drive software manual, and it'll give you some ideas on what the problem could be. But a lot of times it's pretty vague, so you may still want to call us for help. But just as an example, the red banner will appear across the screen. It'll say drive E608, for instance. And then it'll have a small description that says too much dampening in A and or B signals of the direct feedback. Well, in basic terms, that means there's a problem with the encoder on the motor or the cable going to the encoder on the motor, something like that. But just having that E608 gives us a big hint on where to start, at least troubleshooting. If that red banner in the middle of the screen has a 4-digit number, it's typically a controller error, so something that's produced by the controller itself. One example is going to be, and it's going to say CNC in front of that 4-digit number. So just as an example, a CNC 1110 is an X-axis software limit overrun. That's going to be a typically a programming error. That's typically going to be caused by something you programmed into the machine that tells it to go outside the preset soft limits of the controller of the machine. But again, having a picture of that or having, you know, at least that number written down helps us substantially when we start troubleshooting. Some more faults that can appear on the screen are PLC faults. And again, that's going to be a red banner and it's going to say PLC, and then it'll be a number of some sort, typically a 4-digit number. But that PLC error is something that we actually created inside the PLC that we wrote for your machine. And a good example of that is going to be PLC 0008. And it's going to have a message that says spindle drive fault. And with that tells us that there's something in the spindle drive that is telling the controller, hey, wait, we've got a problem. And at that point, you could take it one more step, and if this is a fault that comes up, we would want to go to the spindle drive itself. So we'd have to open the electrical cabinet, in this case without shutting it down, and then look at the spindle drive and see what actually fault is displayed on the spindle drive. And again, I've got one more example for that. If it says OU on the display of the spindle drive, we could look in the spindle drive manual and find out that means overvoltage. You look a little farther and that says it's a DC bus voltage in the drive is too high. And so once again, that's going to give us some hints. Either we've got too much incoming voltage, or the spindle's trying to stop too fast, there's a braking resistor problem, something like that. But at least it helps us troubleshoot a lot faster if we have this information going into the discussion. And so anyhow, the machines will tell you a lot of information. They'll give you a lot of basics to help you start troubleshooting. There's many other issues that we could discuss as far as troubleshooting goes that don't involve errors, but that's all, you know, something we can bring up at a later date, or if you have questions about something specific, we can talk about that at another time. But anyhow, just hopefully that gives you a little idea for when you start troubleshooting. We can make it a lot easier just by listening to what the machine has to tell us. Okay.
1 minute left.
That's good. All right. Again, we understand that we said nothing but general items and things. Again, this was kind of a primer webinar for us. So what we're going to do now is we're going to open it up so you guys can ask some questions. If something happened there? What's the question that Darryl just asked there?
Oh, I actually replied to you.
Oh, you replied to him?
Yeah.
Gotcha.
But one thing I wouldn't mind mentioning is I realized a lot of people had questions about preventative maintenance coming into this. and perhaps it's how to go about preventative maintenance. And we're going to open it up here in just a second. But another piece of information or document that I will make sure we share after this webinar is really we have a preventative maintenance schedule of sorts, weekly, monthly, and I think it's a quarterly breakout of items to go over on your machine. So we will share that as well, and hopefully that helps and addresses a lot of the questions or interest that spiked, that brought you onto the webinar in the first place.
It was definitely the biggest question.
Yeah.
That was asked.
We can send that out to the whole group.
Perfect. So we'll get that information out to you along with the 100-point checklist as well.
Just ready for opening it up?
Absolutely.
All right, we're gonna turn on questions for everybody, so I'll try to manage the microphone as best I can.
Sounds good.
All right.
Does anybody have any questions they want to ask specifically? All right, nobody. We're going to be done here real quick.
Everybody talks about that sometimes.
Can someone reply to know that you can actually hear us?
Did anybody hear us?
Oh, just so you guys know, you do have to turn on your own microphone to talk.
Okay, audio is good. We heard from Eric. Thank you, Eric.
Yeah.
Good deal. Okay, again, then if no one has any direct questions, again, if you come up with one later, please give us a call back. But we would appreciate it we talked about a lot of topics that could be turned into a specific webinar. If there was a favor to yours, if you could, send us a chat or what you might want to do on that, that would be great. But if you don't have any questions, we're going to cut this short. I hope you got something out of this meeting. We work best when people ask us questions, so please let us know what we can do. Some people just went off, right?
Yep.
So appreciate you all showing up. We'll keep you informed on the next one, and thank you very much for attending.
Thank you.